All right. So actually, I kind of doubt anybody watching this video is going to be able to see this, but what I'm saying is more what matters. In fact, you guys can't see it either, can you? Right? But this is the course planner. I'll try to give you a hard copy of this Thursday. I had some trouble with the printer earlier today, so forgive me, I'm a little bit behind. But I will print this out for you, right, and give it to you Thursday if all goes as planned. What you have here is a day-by-day flow of the course, all right? So like today, I'm doing an introduction, that's what we're in right now, overview of the course, and then I'm going to talk to you about algebra. I say review of algebra, that's not really true. It's really going to be more of just an introduction to like a lot of math history. Not all of this is in the book. This is really just my own lecture to you to try to give you a sense of what math is. All right? So, because this course, part of the purpose of this course is to try to expand your mind to see past math as you've seen it before, right? You've mostly seen math in terms of like, you've done arithmetic, maybe you've done, like calculate area of plane figures, maybe some volumes. All of your math has more or less been calculational, right? You probably haven't seen math as, let's say, an art form. And I want to try to open your eyes to the fact that math is alive and full of actually very interesting questions which people study not for their utility, but rather for their beauty. I want to give you a sense of that today, if I'm successful. But anyway, getting back to the boring part. Overview of the course. So this is the day-by-day. Your first homework is due Saturday, and mostly I will explain how to do the homework Thursday, all right? It's, I think, relatively simple. All of these homeworks, every last one of them, I chose problems from WebAssign, and I was mindful of the amount of time it takes. They estimate the statistical average amount of time it takes students to do the problems. So I've tried to create all of these homework problems so that they should phew, caught it. So that they maybe if I plug in this, it'll stop that, huh? So that they're supposed to take an hour. Now, it's probably going to take you longer than an hour, right? But in principle, statistically, they should take an hour, all right? So the homework shouldn't be too horrible in this course, I'm hoping, right? Like, in contrast, I would never make this promise to Math 121, all right? Like Math 121, college algebra, it's a lot of hard work. This course, hopefully not quite as much. Don't ever hold me to this in any other math class I teach, all right? But anyway, I probably should not try to oversell the easiness of the homework. That's pretty much a lose-lose for me. Anyway, first homework is due Saturday. Now, I know at least one of you is having trouble with Canvas not working. If that continues, I will grant you an extension, okay? But I mean, hopefully we'll get things in order. Thankfully, you should be able to log into the WebAssign by just clicking through Canvas. Everybody been successful in that now? Okay, good. I mean, we were having some trouble on the weekend, but that was because the course had not technically started until like Monday, right? So hopefully we're past that. So looking forward, on September 15th, we have quiz 1, right? It's on a Thursday. And so quiz 1 and review for tests. So like the first part of class, I'll give you quiz 1, all right? Then I'll collect it, and then we'll talk about the solution to quiz 1 together, all right? So that's the game plan for that. And then hopefully I'll have that graded, and then you can come pick it up if you want, hopefully on Monday, all right? That would be my intention, is to have the quiz 1 graded, so if you want to, you can come pick it up and look at it before you take test 1, all right? That seem fair? Now, also, because there's only one section of this class, and I'm really, this is not a duplication of Math 115 online, all right? I have made this course my own, so there's really no danger in you taking pictures of your quiz. So like when you're done with your quiz, if you want to take your phone and take pictures of it so you can look at what you did and compare it to the solution, you can do that, right? But you should get my feedback. Actually, I'm hoping to have I should have a grader, an assistant for grading the quiz. I grade tests usually. So if I have a grader helping me with the test. It probably would just be on like a multiple choice part of the test or something, which we're likely to have part of the test being multiple choice in here. There's probably going to be a mix of multiple choice and short answer. On the short answer part of things, like I can give partial credit. On the multiple choice, really not so much, right? So anyway, the point of this is I give the quiz right before the test. This is on paper in class, all right? The only thing that's electronic in here is of course, Top Hat, right? And the quiz, Top Hat quizzes we'll do in class. Those are, I mean, in some sense they're electronic, but you also have to be here, right? And if you're not here for a university approved absence, don't sweat it. I don't count it against you, okay? Well, just when you email me, remind me. When you email me, I'll take that into account, okay? So it is important to email me if you're absent so that I have a record of it and keep account of it, okay? Anyway, so this quiz, while you're taking the quiz 1, I'll be sorting through the Top Hat records of everybody and like assessing your participation. So my intention is to grade participation while you're taking quiz 1. So essentially the day that you take quiz 1, you should have your participation grade for that third of the course. There are three quizzes. There's like one right before test 1, there's one right before test 2, and there's one right before the final. So like each one of these quiz days, I grade your participation. So there's like 3 participation grades. They're each up to 50 points. If you ask particularly good questions and like you're awesome in class, I might give you more than 50 points, all right? But those 150 points, everybody should earn those. All you gotta do is come to class and just be involved. All right, so there's 150 points right there for free. That's, I think, pretty good. Really, the only way to not get those 150 points is to just be chronically absent. All right? Or just to like annoy me. No, I'm just kidding. I like all you. Let's see here. So, where was I? So the test 1 and test 2, they're right after quiz 1 and quiz 2. So like part of my intention with the quiz 1 and the quiz 2 on paper in class is just to give you a heads up. Hey, these are the kind of exercises we're doing on the test. So I want you to give you, a warning. Hey, you don't quite have it figured out yet on the quiz. That way you have a chance to fix it before it, hurts your grade on the test, right? So I do post solutions to the quizzes, and I do intend to have them graded so you can pick them up. I can't give them back to you in class before the test. There's just not time for that, right? But I hope that this is, helpful to you to do your best in here. And the other thing I think is I allow you a page of notes, right? A page of notes. So the quizzes and tests are closed book, closed notes, except I allow you to bring a page of notes front and back for the quiz and also for the test, right? So I would say as you're doing homework, I would be like summarizing some of the information that you get and thinking about what you want to bring with you to the quiz, right? If that makes sense. All right. This is a old school roster. If you can just find your name and check it and pass it back, and then we'll get to the other side, just to double check on the Top Hat in case. And also, if you're not in Top Hat, if you could just make a note on this page, that would help me, just to try to, because I'm trying to take attendance in here, All right. Yeah, you can sign it or check it, whichever you want. So, okay. So I think there are about 12. There are 12 homeworks. Each one of them is due Saturday at 11:59 p.m. I would suggest that you do them before then, but anyway. So pretty much every week there's a homework due. I try to make the homework that are due on test weeks a little bit lighter. And also homework 13 is the exception to that. So this homework 13 is on the material covered before Thanksgiving break, but I didn't want to make a homework due in the middle of Thanksgiving break, so I pushed it to the week after, if that's okay with you guys. So that's pretty much it. There are 300 points for the 2 tests. There is 250 points on the final. And the homework through WebAssign is worth 180 points total. So, any questions about anything before I get into my math? Yeah.
Yes. I was wondering, for the quizzes and the test, are we just calculating numbers, or are there also conceptual questions?
There is conceptual. There is numbers. There's. I mean, let's look at the topics here. So, yeah, they're written answers. Let's see here. So Thursday we're talking about basic properties of sets, complements, subsets, Venn diagrams. So there you might even have a question that's like draw a Venn diagram and shade in the part that represents the intersection or the union. We'll talk about that. So it'll be like a picture even. There's things called truth tables we'll do. Let's see here. So I don't really see any kind of equations so much for test one. Test one mostly is about set theory and logic. So like most of the answers would be like funny looking curly brackets with things in it, or sentences, truth tables, things like this. And also some trivia that I'm going to be talking to you about today. So let's see here. And then now, but in contrast for test two, so test two is where I stopped looking. Well, personally, I don't think the stuff we cover in this middle third of the course is beautiful. To me, it's not beautiful, but it's necessary. It's financial math, all right? So the middle third of the course, we cover like simple interest, credit cards, consumer loans, home ownership, and then like some things about counting, permutations, combinations, probability, basic things in statistics like median, mean, mode, normal distribution, z-score. If you've had Math 201, you know all these things like ad nauseum. Now we're not going to go too deep in here. I just want to give you a basic literacy in these ideas. But there are equations and formulas for sure. So you definitely, like, do you need a calculator for test one? I don't really think so. Probably not. Do you need a calculator for test two? Yeah, you need a calculator. You need one that can do powers and things, like, because simple interest is something like something in parentheses raised to a power that could be like the 1.7 power or something. So you need a calculator that can do that kind of stuff. Yeah.
I have two questions.
Go for it.
How much time will we have for quizzes and tests?
So the test will be the full period. The quiz I want to make a little bit shorter, so because I want to like go over the answer to the quiz in class. So I would estimate the quiz should be like 50 minutes, whereas the test will be the whole time, but the test might actually be similar length to the quiz, so you just finished early. Yeah.
My other question is, you said we don't necessarily need the calculator, but if we want the calculator, can we have it on the
Yeah.
quizzes?
Yeah, you can have any calculator you want on all the tests in here.
Okay.
Again, do not hold me to this in my other math classes. Like in 121, I won't allow them to have graphing calculators because like a lot of 121 is graphing. So if they have a graphing calculator, it's like, we were sold on high schools using graphing calculators to increase the mathematical literacy of the nation 30 years ago. How'd that turn out? Yeah, I wonder.
Actually, I have a follow-up question.
Uh-huh.
So the quiz and the test, are those on paper?
Quiz and tests are on paper. That is true.
And so can we use our phone calculators, or it has to be like a physical?
I can't let you use phone. That is, thank you, good question. No phones. Unless, of course, you have a documented like condition. Some people have trouble with blood sugar that they have to like monitor their glucose using a phone. Like there's, phones do all kinds of crazy stuff. So if you got something like that, that's obviously an exception, but the default is no phones in here because, as you know, phones are computers. So, yeah. I mean, it is true you probably can Google the answers to many, many things on the test, but that would kind of defeat. It'd be kind of like going to a marathon and at the start calling a cab. It's not really the point of the marathon. It's not just the process of getting there from point A to point B, it's how you go there. Yep, other questions? Good questions. Okay. Let's see here. I think I pretty much covered everything in terms of this breakdown of the course, so let me get into my PowerPoint here. Oh, good. Oh, I know what I forgot to write on the board. I forgot to write my office hours and where my office is. Let me just tell you, it's in the syllabus, right? My office is in 4386M, which is, do you guys know where the math department is? Like in the big hallway over there. So the long hallway on the other side of the top fourth floor, all the way down on the end, there's this interdisciplinary suites. My office is in there. So they ran out of offices in the math department. I lost my office when I came back, and so now I've been booted over to interdisciplinary studies, which is okay. It's actually kind of a big office, but anyway, I'm down there if you want to find me. My office hours are Monday, Wednesday, Friday, 12:50 to 2:10, and Tuesday, Thursday, 11 to 2. Again, all of this is in the syllabus. And if you click on the link to my personal website, you'll see I have like a big graphic of the whole schedule and other fun things there if you want to look. Okay, so let me make sure my camera is where I want it to be. There we go. Thanks. Let me see if I can get some of the lights off, but not an, ow! You know, you forget how much it hurts to hit your elbow until you do it. Let's see here. That's not going to make any of you go to sleep, is it? Okay, good. I'll work on that then. So this is Math 115, obviously, Math for Liberal Arts. And I want to tell you the story of algebra, all right? So, and to tell you that story, oh man, you know, I wrote this PowerPoint like yesterday. You'd think I'd remember I put this information here I was just telling you. Dummy. Me, not you. There's my personal website. We can click on that actually. Foolishly. So here's my personal website. Hey! PowerPoint. Jerk. Huh. Well, let me end slideshow for a second here. So this is my personal website. Notice that I have like a link to the playlist on YouTube there. If you ever want to go to it through there, you can. It won't work right now because there's nothing there until after I post this lecture, right? And down here is like my fall schedule. We're right here, right? My office hours I have afterwards and there. And so you can see where I am different times if you want to track me down. And then if you keep going down, I've got stuff from old teaching, lots and lots of stuff I've done. And then if you keep going and going and going and going and going and going and going, eventually you'll find pictures of my children. I have 5 kids. They're much bigger than this now. I need to update these pictures. So like, Hannah's 16 now. Wait a minute, 17? 16. 16. This is Isaac. I think that's Matthew, actually. This is Matthew here. I explained to you this picture. He was just told, no, you cannot have soda at the pool. He was not happy about this. To this day, that boy loves soda. So this is Matthew playing with my youngest son, Benjamin. Benjamin's now 5. I'll update these pictures eventually and show you more. So they're playing Star Wars, I think, at Disney World back when we used to consider going to Disney World. Here's the, this is gone. This is like, I don't know, part of the Star Wars thing at Disney World now, you know. That's from the Honey I Shrunk the Kids playground. That's long since gone. But anyway, so I'm blessed. I have 5 children. They're all great. And my wife's pretty nice too. Let's see here. I mean, she married me. Let's see here. So enough about this stuff. Let's get back to the course. Because at some point I'm going to regret not showing you the end of the presentation here. Let me get on with it here. So I think I've already told you pretty much all this information, but I will again post this PowerPoint afterwards so you have it yet again, the breakdown of homework, quizzes, tests, participation, final. Again, participation, we should all learn, right? And also, I should mention, if you're feeling sick, stay home. I do not like rigorously enforce the attendance policy, right? Like you have to miss a lot of classes for me to take points off for that. Now, if you miss a lot of classes and don't communicate to me why you're missing classes, that will hurt you, right? Like if you miss 10 classes and never tell me why, I'm probably going to take points off. But if you miss 10 classes because you had pneumonia and a hacking cough and you didn't want to get around other people, well, thank you for telling me that and not coming to class, right? That's fine. And I don't insist you to go to a doctor's and get a doctor's note in that case. Like, I trust you. You can email me and tell me I'm feeling horrible. I know doctors won't help me anyway. I would like to just rest. Can I please just watch the video? That is fine. Just the key is communication, all right? If you're going to miss class, you got to tell me why, all right? So I want to keep you accountable, but I also don't want to like force you to go to the, doctor or something if you don't want to. All right, enough about that. Some pro tips. I'm sorry, I've been watching too much YouTube lately. So keep a record of your work on homework in a binder, be organized, plan time to complete the homework, if possible form study groups, seek my help when you're stuck on a problem. But remember, it's important to remember to include details when you ask me the question. Like one important detail, I'm a Math 115 student. Like that matters because I have like 200 students and I don't remember all the names, I mean, I will, I'm sure, get to know some of you as we go on, and I would like to get to know all of you. But do remind me who you are and why you're asking the question, yeah? And I already told you about the page of notes. Most of the testable items are covered in homework, but on occasion I add a problem in class, which you might see on the quiz or test. Today is an example of that, all right? Okay, so lectures are posted on YouTube. I think I already told you about all that. I should also mention, like, what are examples of unapproved absences, right? So I've told you what's approved absences. I've told you if you're feeling sick, you don't have to come to class. Like, what would be examples of unapproved absences? You're proposing marriage to your significant other. For some reason, on like Tuesday or Thursday morning, in the middle of the semester. Yeah. No, I do not approve of this absence. I'm sorry. Oh, I'm going to take my honeymoon in the week of fall break because plane tickets are cheaper. No, I mean, we all make choices. Congratulations, have a lovely time, but I'm not going to approve your absences. No, I refuse. You are planning to miss my class for a week in the middle of the semester. This is not a good pattern for your marriage or life. So, I'm sorry, I speak from, in the past I've always had, I do have this like subcurrent of students at Liberty who plan to miss like the first week of the semester from a honeymoon or something. And like, I understand their, reasons, but it's just like annoying. You're planning to miss like one of the most critical weeks in the semester. What are you doing? But anyway, I mean, I understand, but still, I cannot approve of it. Okay, so, camping out for a Chick-fil-A grand opening. I've had that one before. No, not an approved absence. Okay. Snowball fights. I mean, I approve. Don't involve me. Yes, prank wars of any kind. Again, I generally approve, but although I was sent an email about hazing, so we're supposed to discourage hazing in like club sports here or something. I don't know, like, I was like, so we're against hazing then. Okay, good. But, oh yes, training poodles how to fly. I need to explain that. So, do you guys know about training poodles how to fly? No? Okay.
So, you're at the age now where you may start feeling certain urges to buy.
Well, at least you couldn't see it. So you guys have seen that ad? Silence. Ha! Oh. Oh, Amazon. What's Amazon? It's good that we know about it now. All right, stop. No, I don't want to. You stop it.
Welcome to Raul's Wild Kingdom. Coming to you live from my apartment. How about that? Okay, first thing we're going to do today is check out the wonderful world of tracks. This is my friend Tommy. Tommy, say hello to the nice people. Hello. Isn't he great, huh? Okay, so the turtle is a member of the reptile family, and he's got this hard protective shell, which keeps predators away, also provides him with his own home when he sleeps. Oh, and he's got this tiny, teeny little leg, which makes it move real slow. And not many people know this, but the turtle is also nature's suction cup. Watch this. Do you see that? It stinks! Oh yeah, what else I got for you? Yeah, check this out. This is my ant farm. Now, ants are amazing. They can carry 50 times their own weight, and they work for weeks and weeks building these intricate little tunnels. They hate it when you do this. Oh, look! They're really bad now.
Where'd you find this guy?
Me? I thought you hired me.
For those of you just joining us, today we're teaching poodles how to fly. Come here. Are you psyched? Are you ready? Okay. Here we go. Get ready and fly! Oh, man. You know, sometimes it takes them a little longer to learn how to do it right. Okay, come on. Gigi.
So, largely speaking, your generation has not seen UHF, right? Have you guys seen UHF? You have not. You should go watch this movie. It's hilarious. This is Weird Al's masterpiece from 1988. Which, I don't know, it does have parodies of like Rambo and stuff like that, so if you don't know what Rambo is, I guess that could be, you probably know what Rambo is, I don't know. All right, let me get back to the serious business. So, also not an approved absence. All right, it's here. All right. I got to figure out how to get it to watch videos without doing all that, oh well. All right, so we already talked about the course planner. I will give you a hard copy of that next time. So finally, let's talk about math. So mathematics in ancient times, I think we have a wrong picture of ancient societies. A lot of times you get this picture that the ancients were more simple than us. I don't think that's really accurate. I mean, if you look at the architecture of the ancient world 2,000 years before the time of Christ, pretty much as long as we have really good records of human history, there has been significant architecture which indicates that we've had an understanding of geometry and trigonometry which is fairly deep. One of the differences between now and then, though, is that in the ancient times, like that mathematical knowledge was really isolated to a select core group of elite individuals, right? But it is certainly true that the Babylonians, the Chinese, the Indians, and many other ancient civilizations did have understandings of number theory, parts of algebra, calculus, and trigonometry. All right. Here's some, this is a picture of one of the oldest known Chinese mathematical works. And I think this is from I'm trying to remember. Oh my goodness, I can't remember. This is one of the Babylonian Plimpton artifacts or something. One of these things that helped translate the Babylonian language to the other languages. Anyway, so there are some very ancient records of civilizations having understandings of number systems, right? It's nothing new. And then the Greeks came along, a little bit before the time of Christ, maybe a couple hundred years, and they started thinking for its own sake. They started thinking about methods of proof, right? And they axiomatized like Euclid's axioms, right? So the Pythagoreans, they were religious in their application of numbers. They really thought that everything is numbers, and for them it was more of a religion even than just math. Euclid, like Euclidean geometry. Diophantus studied integer solutions to equations. Archimedes is a very interesting person. He built war machines that could throw things the size of buses from Syracuse out into the sea against like an invading fleet. The things that Archimedes was able to do with mechanical work is really astounding. Archimedes wrote a book called The Sand Reckoner that so it was often like a phrase in ancient times you hear like the sands on the sea, they can't be numbered. And Archimedes was like, really? I'll number them. And he wrote this book that explained like a number system to count for really, really large numbers. I don't think we actually have a copy of it anymore, but they're like historical records of it. That's the case with like a lot of the mathematical works from this time period. We have records of their influence on other mathematicians going forward, but we actually lost the original works, which is a great contrast to the scripture, right? So like it's interesting, if you look at the Bible, there are tons and tons of early bits and pieces of the Bible, and every year there's an increasing database on known early parts of the Bible. In contrast, other ancient works of literature, there's far less record of. So anyway, the Greeks used letters to denote shapes under study, and they began to ask symbolic questions. But their symbolic questions were always, in some sense or another, tied to a question of geometry itself. All right, so like, and then a little bit later, actually a lot later, I cannot pronounce this. Can anybody pronounce this? What's that?
Al-Khwarizmi?
There we go. So this was an incredible mathematician of that time period, a Persian mathematician who basically invented much of what we know and love as algebra. Right? Algebra is a word from Persian culture, and he explained method of completing the square to solve quadratic equations. He explained how to balance equations, adding and subtracting terms, the idea of cancellation. He's called the father of algebra by many, this fellow here. And his work was much larger than just mathematics. He did all kinds of work in the natural sciences and other things. It's really an incredible intellectual of his time, all right? Very much like a figure whose stature could be compared to like Newton or Gauss or somebody like that later in European history. There was a Latin translation of his book on arithmetic, which introduced the decimal number system, give or take, to European audience in about the 12th century. So before that, how did they do numbers? Well, remember the Roman Empire? They had Roman numerals. You ever try to figure out the date of a movie at the end in terms of the MCXVII? Yeah, it's not good, right? So imagine doing all of your numbers with Roman numerals. It would be rather hard, right? So changing from that notation to a more friendly, like decimal-based notation was an important step towards making computation understandable. Anyway, you can read more about this guy's work at this Wikipedia article if you like. Wikipedia is really good for math for the most part because like Wikipedia tends to get edited by an army of nerds, and so it tends to work. Let's talk about completing the square. So what is completing the square? Maybe you remember, maybe you don't. Let's talk through it, all right? Ax squared plus bx plus c, this is a quadratic equation, right? So to complete the square, don't worry, this is not on your test, okay? But I wanted to walk you through it, just to remind you how it goes. So what we do is we take half of the part with b, we divide by it, and then we group it into a square, right? Now, to be fair, if I multiply this out, I get back the ax squared plus bx term, all right? But I get an additional thing. I get b squared over 4a. Oh man, I'm missing a square right there. That's supposed to have a squared. I'll fix it before I post it, okay? I'll try to remember to do that. Let me correct that. That should be a squared right there. Anyway, so I have to add that to the other side to be fair, and I move the c to the other side. There you go. And then to solve this, you just take the square root of both sides, and you have to allow for plus or minus because of the way the square root works. This is solution by completing the square. of a quadratic formula. Some of you learned this in high school algebra, right? Show of hands, who remembers this vaguely? Good, good, good. Why is it called completing the square? Did you ever ask this? I mean, I satisfied myself with the answer, oh, it's because you're like grouping everything with the square into one thing, and that's like completing the square. And that answer satisfied me, but it's not really the answer. The reason this is called completing the square is something much more interesting. And it goes back to that Greek understanding of mathematics, like thinking of equations in terms of their underlying geometry. So polynomial equations used to just be shorthands for questions about like geometric questions. So this is the first in-class exercise. I want us to try to do this together. And so I want you to try to explain why it is, if we have x squared plus 10x equals to 39, right, how we can solve that in terms of this diagram. So this has area x squared, right? This has area what? 10x, right? So I want to think about how can we, and this, so this, the total area here, right, is going to be 39. The question is it possible to find such a number x? Right? Well, whether or not there's a solution to x squared plus 10x equals to 39 corresponds directly to the geometric question, can you find a length to make this area be equal to that? All right? So what I suggested down here is we should think about cutting the red box in half. All right, so let me do it with markers over here. I'll get you started, and then I'm going to put up a I wanted to try out the top hat quiz function today. So we'll see how it goes. Get the lights back on in here. All right, if I can find my markers. All right, so we've got this is x, right? And let me go ahead and cut that red box in two. All right. If I do that, if I take half of it, leave it there, and put the other half down here, like this, what would this would still be x, right? And this would still be x. How long are these sides now? They were 10 over there. Now they're 5, right? So as it stands, this is equal to what? What's currently on the board, that would be 39 units of area, right? So, oh man. I've almost solved it. Now think about the terminology. Complete the square. What should you do? Uh-oh. I may have just closed somebody on Teams. I'm really trying to, I think we should do the lectures, like I said, with the video. Where did my top hat go to? Did I close it? Dummy. Me, not you. Come on. Give me a second here. I'll give you a chance to play along here. Let's see here. question, multiple choice. It is impossible. So we'll put A is impossible. B, the area of the completed square is, let's see here, any answers? What's the area of the completed square? Anybody want to give me an answer to put in here? So let's make one answer 100. And let's see here. Oh, don't look, you should. Everyone close your eyes. I said save. I said save. Why would it save? Come on. Come on. Why do you mean I can't look? There we go. So you have 20 seconds. Do you think it's impossible? The area of the completed square is 100, or the area of the completed square is 64? Time's running out. Quick. Quick. Oh no! Is it going to show us the results? Come on. Show me the numbers. Did it show you guys? Very good. So obviously I didn't give you guys enough time to respond. I'm sorry. I'll do better next time. So like next time, hopefully I'll have the quiz written ahead of time for class. I moved like 2 weeks ago. I'm running behind, guys. So I'm doing the best I can here. But so I'm trying to do this kind of thing in class to do the top hat. This is an example of what I mean by the top hat exercise. Let me go through it here and explain what I mean though. So the reason the answer is C is just this, right? If you complete the square, right? This would be a what? A 5 by 5. So to be fair, if I've added a 5 by 5 square here, that means what? I've added 25 units of area, right? So I have to add 25 over here, which gives me 64. I have a square with area 64. What's the length of its side in total? 8, right? So that means that this has to be 8. It has to be 8 by 8, which then tells us that x is equal to what? X plus 5 equals to 8. So apparently x is equal to 3. So this is how you complete the square by picture, right? And this is actually how mathematicians of like the medieval times thought about algebra. And they thought about it as it was connected to a question of geometry like this, right? So if this is the idea, then could you, yeah? Oh yeah, there's other ways to do this problem for sure. Yeah, you might be able to factor it. I actually haven't thought about it. You might be able to factor it. Certainly you could use the algebraic method of completing square. You could use, a quadratic formula. There are many ways. Sorry about that. The point of this exercise, though, is I wanted to show you why it's called completing the square. It actually goes back to this idea. And my larger point here, though, is to alert you to the idea that in the medieval times, the mathematicians, they thought of the variables like x in terms of that actually being a literal length. Okay, so with that in mind, if you think about x cubed, what would that be? What would x cubed be? If x squared is an area, what would x cubed be? It would be like a volume, right? So what would you think about x to the fourth? Could you think about x to the fourth if you're a medieval mathematician? Would you do it? Why would you do it? X to the fourth would be like a hypervolume. Is that physical? Is that something you can actually think about? Is that reasonable? They would have actually, there were mathematicians who rejected look at variable powers larger than 3 because they only thought of variables in their connection to geometry. All right, so that's part of the importance of the invention of algebra and this systematization of algebra is it divorced questions of algebra from questions of geometry necessarily, right? And like, you probably haven't ever struggled with this because you were not a medieval mathematician and you just did algebra that was put in front of you, right? So like if somebody put an x to the fourth down on your paper, you're not like, that's unphysical. You can't do that, right? I mean, no one would, I mean, come on, right? But that was a conceptual hurdle that European mathematicians had to get over. So moving on here. In the 15th and 16th centuries, we learned how to, Europe actually, learned how to, I should mention, quadratic equations were understood by all kinds of cultures from ancient times. It's really hard to pin down exactly who solved the quadratic first. Any culture with a sufficiently documented history of their scholarship will give you evidence that they solved the quadratic equation 3,000 years ago or something. All right, it's hard to say. But it seems that the cubic and the quartic equations were first solved by European mathematicians, at least in the 1600s. So Faro and Tartaglia solved this cubic equation. That's actually not quite accurate. They solved, that's a lie. I mean, it wasn't one cubic equation they solved, because at this time in history they also rejected negative numbers because they only could think about positive numbers for various like geometric reasons again. They're still stuck in that geometric idea. So when they solve the cubic, they're actually solving it in terms of like some sort of completion of a cube. It actually had this kind of idea. And there's an excellent YouTube video on this if you want to watch it. I can send you a link. Anyway, and then so after that, Cardano published Faro and Tartaglia's solutions to the cubic along with a solution to the quartic equation, which is this thing, in his 1545 book Ars Magna. So I said 1600s, that obviously should be what? That's a typo. 1500s, otherwise this is like violating causality, which is never a good thing. So there was no time travel involved here, that's just a typo. And then in 1572, Bombelli published his algebra book there, which explained that annoyingly, even to solve a cubic equation with real coefficients, you have to use imaginary numbers. So, all right, all of this, so great. The ancients solved the quadratics. You know, in the 1500s, we solved the cubic and the quartic, right? What's next? What comes after 4? 5. So can you solve the quintic equation? The quintic, yeah. Well, we'll get back to that question here in a second. I should mention some important names. Fermat invented geometry, analytic geometry, like the idea of connecting numbers to points in the 1600s there. His work led Descartes to write his very influential book on analytic geometry. You've all studied like graphing in the plane. Those ideas really were cemented not that long ago. In about 1600, we started understanding XY graphs and looking at things like that. Here's some exciting pictures of Fermat, Descartes. I had a class with a student who pronounced this Descartes, so sometimes I still call him Descartes. because it gives me joy. This is a rather silly looking picture of Euler, but Euler's not a silly man. He did everything. To this day, it is breathtaking what Euler did. Euler was also, it seems he was a born-again Christian. He was a devout Christian. He believed in the inspired Word of God. And it's a very interesting testimony if you look into it. But he also had a lot of children. Then there's Lagrange, who's the father of what's called Lagrangian mechanics. Lagrange and Euler both actually, they developed something called variational calculus. The way we do physics at its base is in terms of something called classical field theory. Euler and Lagrange both foundational to that. But those things were done, what now, 300 years ago. Gauss really is by the end of Gauss, we're entering the modern period of mathematics. Gauss made deep advances in multiple fields of math: non-Euclidean geometry, complex analysis, differential geometry of surfaces. By the age of 18 or so, he wrote this masterwork which solved problems in number theories which had been unsolved for hundreds of years. He's a formidable mathematician, but also kind of a jerk. He had this habit of saying he did other things other people published, but he hadn't bothered to publish them. It'd just be like, oh, he's like, somebody publishes something, be like, oh, I already did that. We're like, why didn't you publish it? I just think it was good enough. It's like, so you've already done it, you didn't think it was good enough, but now you got to talk about it. It's like, I don't know, just like his habit of like not publishing things and then taking credit for them, kind of annoying. But anybody who's a math major knows a lot about Gauss. His work is influential to this day. All right. So Lagrange is important to my story of the quintic. Lagrange spent decades trying to solve the quintic equation, looking at the next order up past the quartic, the quintic. All right? And he tried and tried and tried with kind of the same methods that they tried to solve the quartic and the cubic. And he wasn't successful. But the thing is, Lagrange is he's no dummy. So the rest of the mathematical community at that point was like, well, if Lagrange can't solve it for decades on end, and everybody else hasn't been able to solve the quintic for like 100 years now, maybe it can't be solved, right? And then at the start of the 19th century, Abel, he gave a convincing proof around 1820 that the solution for the quintic equation could not be found. So we've got formulas for the quadratic, the cubic, the quartic. My wife studied solutions to the cubic and the quartic in high school because she went to high school in Hong Kong and had advanced level mathematics, but like we don't teach those formulas to students in high school because...
You're welcome.
Exactly. They're really, really lengthy. I mean, just quite something. So this quintic equation in general doesn't have a solution. Now, look at the date on that, 1802 to 1829. He did not live long. So this dude died of tuberculosis, as was fashionable in that time. And there's no telling what he would have done if he'd lived longer. He was an incredible mathematician, really doing deep things, even in today's terms. And then comes along this Galois. Galois was a very interesting character. This is a sketch of him when he was like 15. I think he was Norwegian. Galois was French. And he also died, how old? Maybe 21, I think. But not of tuberculosis. This one died of a duel. So we don't exactly know the details, but he was not successful in getting his work published in his lifetime. There are a number of influential mathematicians who were made aware of his work, and I think they just didn't understand it. So they didn't really publicize it or really. But it turns out that he not only solved when you could solve the quintic, he explained when you couldn't, and he developed something we now call the Galois group, and this really gave birth to what we now call group theory. All of that from just chasing the question of how do you solve the quadratic equation to the next level has led to this. So let me show you a short video here.
I need to find the best way to make
Of course. I'm sorry. I need to put ad block on this machine. My bad. Here we go.
In which they teach you all. The analogy I make is, imagine that you have an art class in which they teach you only how to paint fences and walls, but never show you the paintings of the great masters. So you never see Picasso or Van Gogh. What would you think of mathematics? You know, of art? If you have an art class like this, you would think it's only about painting fences and walls. You would think it's the most boring subject ever. And that's what happens in mathematics, unfortunately. The kind of material that we present to our students in school, and it's not just, it's universal everywhere around the world. This material, most of it is more than 1,000 years old. Just think about it. What do we usually talk about? We talk about numbers, we talk about quadratic equations, Euclidean geometry. Euclidean geometry is 2,300 years old. And it's a beautiful piece of mathematics which actually laid the foundation for the axiomatic method and so on. But in literature, around the same time, Homer wrote, Ulysses and Iliad. But in our literature classes, we don't stop at Homer. We continue. We read more recent works of literature. Likewise with art, likewise with science, with physics, with biology, and so on. So, for instance, what are the things which are missing? No Euclidean geometry. And they sound complicated and abstract, but in fact, it's closer to the real world. The surface of the Earth is spherical, right? And if you try to do geometry on a sphere rather than on a plane, that's a non-Euclidean geometry, where the sum of the angles of the triangle is not 180 degrees, but is greater than 180 degrees. That's all it is. So, but in our classes, the Earth is flat, as it were, because the Japanese systems are so big. There are many other interesting topics which could be presented in school. For example, cryptography, which is now widespread everywhere, from banking to cryptocurrency and so on, based on what's called clock arithmetic, where you do calculations where the way you do calculations with time, where after 12, you have, well, in different countries, in the United States, after 12, instead of 13, you say 1 p.m. In Europe, you usually go all the way to 24, but 24 is like 0, and you don't say 25 hours, but you say 1 o'clock, and so on. So, likewise with angles, you go up to 360, then it becomes circular, it goes back to 0, right? And so, this type of clock arithmetic is very important in mathematics, and you can look at solutions of equations subject to this rule. And this is exactly the type of mathematics which is at the root of modern cryptography. So, for sure, we can teach our students this stuff. When we talk about symmetry, like a Rubik's Cube, things like that. So, unfortunately, our math education today is very limited, and very few people get to see the masterpieces of mathematics, the way we see masterpieces of art.
So if I had another 5 minutes, I would show you some more clips of him. And the reason I want to show you some clips of him is so you can gain an appreciation into how a mathematician looks at math. Because it's hard to understand that unless you've actually walked in their shoes. But to a mathematician, the reason that mathematicians study math is the same reason that artists make, pictures and things like that. It's for the beauty, yeah? And, I think that's lost somehow in our educational system. But to me, a lot of the reason to study mathematics is because it's part of God's general revelation, and it's another one of those places where we can, gain a sense of awe of what He's created. Math is part of that. But anyway, that's all for today, so thanks, guys.